Yay! I have the keys to unlock Pocket Ronnie. Okay, we're going to be talking about the discriminant. So this is the quadratic formula. In the quadratic formula, this part right here is called the discriminant. Alright? We can look at the discriminant. We can look at pretty much everything under the radical and tell what kind of solution we're going to have using quadratic formula. Okay? So, once we have our equation laid out, we can know what B is and A and C, and we can plug them in here and look at and tell what kind of solution we're going to have. Our choices, we're either going to have a real number or we're going to have an imaginary number. So those are our two choices. If we have an imaginary, there's nothing more to break it down from there. Okay, an imaginary number is an imaginary number. But if we have a real number or real solutions, we can break it down even into more categories from there. If your discriminant is a perfect square, right here, if you're a perfect square, that is a good tip that you can factor that equation and you can solve it from there. If you have a perfect square, then your solutions, they are real numbers, but they are also rational numbers. What is a rational number? A rational number is a terminating or repeating decimal, like 0.75. That terminates. It's an ending decimal. It has an end to it. So 0.75, which is the same as 3/4. So 3/4 is a rational number. Like 1/3. 1/3 is 0.33333333. That's a repeating decimal. So 1/3 is a rational number. All right. Once you can determine that you have rational solutions, then you can also look at, are your solutions unequal? Do you have two unequal solutions or do you have two equal solutions? Majority of the time, your solutions will be unequal. If your discriminant equals 0, then that means the two solutions will be equal. And I will do an example of that. So if you have real solutions, they can either be rational or they can also be irrational. What is an irrational number? An irrational number is a non-terminating, non-repeating decimal. Pi is 3.14159 something something something. That is an irrational number. So you have to look at the decimal. If it doesn't repeat itself and it's never ending, then it is an irrational number. All your irrational solutions, they will always be unequal. Okay? They will never be, you will never have two solutions that are the same for irrational. Irrational solutions, they will always be unequal. Remember, when we're dealing with quadratic formula, we're dealing with quadratic equations, and quadratic equations, the highest exponent is a 2, which means we will have two solutions. So when you're dealing with irrational solutions, you will have two solutions that are unequal. Okay, so let's look at a problem. Let's look at 13E, number 1 and 2. You have this equation. Always make sure your equations are set equal to 0. And then here is my A, here is my B, and here is my C. So we can just look at the discriminant. So I am just going to look at the discriminant. The discriminant is this part of the quadratic formula. B squared minus 4AC. The square root of B squared minus 4AC. So I'm just going to plug in my numbers from here. So B is 7, so that'll be 7 squared minus 4 times 3 times positive 2. Okay, because this will tell me what kind of solutions am I going to have. So that would be the square root of 49 minus 4 times 3 is 12, times 2 is 24. So that's going to be the square root of 25. The square root of 25 is a perfect square. That is 5. So when this is a perfect square, first off, the square root of 25, is that a real number or is that an imaginary number? It's a real number. So therefore, I know that they want you to say, they want you to tell the nature of your solution. Okay, so the first off, I know I'm going to have a real number. Okay, once I know it's real, then I have to determine, is it rational or irrational? when you have a perfect square, you will have rational solutions. And there's only one special case when the discriminant equals 0, your solutions are equal. So there I know my solutions will be unequal, because there's only one special case where your solutions are equal. So square root of 25 is a real number. That's how I got that. Then when this is a perfect square, tells me they will be rational. And then there's only one special case where they're equal, and this is not it, so they are unequal. Okay, so this tells you the solution. This tells you the nature of the solutions, what kind of numbers we're going to have. And then in number 2, you solve it. So when this is a perfect square, that tells you that this can be factored. Okay, so then you can factor that to solve. So that would be a 3x. We're in a positive world, so everything's positive, and x. And then 2, 1, make sure that gives you your middle term. That would give 6x, 1x, and that does give me a 7x. Okay, so I can see now my solutions are going to be x equals, moving that over would be a -1, and then dividing by 3, so that would be -1/3 is one solution, and then x equals -2 is one solution. And this matches what I just said. These are both real numbers. They're rational. This is a rational number because 1/3 is a repeating decimal, -0.33333. So that is a rational number. This is a rational number. Rational numbers can be whole numbers. They can be negative or positive, and they are unequal. Neither of my solutions are the same. So this matches what I just said. Okay, let's look at 13E, number 3 and 4. Okay, we have this equation. It says tell the nature of the solutions. So anytime you're telling the nature of the solutions, you look at the discriminant. Okay, the discriminant can tell us what kind of solutions we're going to have. This part of the quadratic equation is called the discriminant. So we can plug in our numbers. So that's A, B, C. Don't forget B is -5. The sign in front of the number goes with the number. So plugging in our numbers, B is -5. That's -5 squared minus 4 times A times C. Alright, -5 squared. That'd be a positive 25. Minus 4 times 2 is 8. Times 4 is 32. That would be the square root of 25 minus 32. What kind of number are we going to get? Positive or negative? Negative. So the fact that I can see that I have a negative number, let me subtract that out. That would be, can't believe I'm not doing this in my head, 7. Okay, 7 plus 5 is 25 and 32. Okay. So, -7. So, that's a negative. Negative under the radical. What does negative under the radical mean? Means imaginary number. So, you can tell here, anytime you get a negative under the radical, you're going to have an imaginary solution, an imaginary number. So, tell the nature of your solution. You know you're going to have an imaginary number. And then once you have an imaginary, you can't break it down anywhere from that. We don't break imaginary numbers into rational or irrational. We only break real numbers into rational or irrational. So once you have an imaginary, that's all you do. You can just say you have an imaginary solution. Number 4, you then go on to use quadratic formula. Go back and use the whole quadratic formula to find your exact solutions. Alright, we're looking at 13E, number 7. So again, the problem says tell the nature of the solution. There's my A, B, C. Don't forget for B I'm using -4. For C I'm using -7. When we're telling the nature of the solution, we can look at the discriminant. The discriminant is this part of the quadratic formula. So, because this will tell us, do we have an imaginary number or do we have real numbers? And then from there we can break it down. So, plugging in my numbers, B is -4 squared minus 4 times A is 2 and C is -7. Keep up with your signs. This is a positive 16. You can see I'm going to have a negative times a negative, which will give me a positive. 4 times 2 is 8, times 7 is 56. So I had a negative 4 times a negative all of these, so a negative negative turned out to be a positive. And that's going to be the square root of 72. 12, yeah. Is the square root of 72 a real or an imaginary number? That's the first thing you have to ask yourself. You break it down to real or imaginary. Well, there's no negative under the radical, so therefore I have a real number. And then when this is not a perfect square, is square root of 72 a perfect square? No. When it's not a perfect square, then it's irrational. Because you can go do square root of 72 in your calculator. Matter of fact, let me do that. Square root of 72 is 8.48528.137 and so on. This is a non-terminating decimal, which means it does not end and it does not repeat. So when the decimal does not end and does not repeat, it is irrational. So this is an irrational number. So therefore my solutions will be irrational, because this is part of my solutions in quadratic formula, because I will have this plus or minus here in the front. So I'm going to have part of my solutions will be plus or minus square root of 72. So since I know my solutions are going to be plus or minus square root of 72, then I also know that they're not going to be equal. There's only one special case where your solutions are equal, and it's when the discriminant equals 0. Here the discriminant does not equal 0, so they are not equal. So again, my solutions are real because this is not an imaginary number, and square root of 72 is an irrational number, and in my solutions I will have a plus or minus that, which means I'm going to have a plus square root of 72 and a minus square root of 72, which tells me these are not equal. So that tells you what your numbers will look like. Then for number 8, they want you to go and solve it, so then you can go ahead and go back to the whole quadratic formula to find out what exactly your solutions are. The good thing is when you solve these, you have already done part of the quadratic formula. You've already done this part. So you know when you go plug it in, you already know that this is going to be plus or minus square root of 72. Don't make it harder on yourself. Just take this and put this back in for b squared minus 4ac. You've already done that work. So now you know, because like here, I could just go x equals negative b. That would be a negative 4. Plus or minus square root of b squared minus 4ac. I did all that. That's 72 all over 2a. 2 times 2. So now I can finish it from there. I've already calculated this, so I don't need to go do it again. So then I can simplify this and find out my two solutions, and this shows that they are not equal. Alright, let's look at 13D, number 5. So far we've looked at how the discriminant can show you if your solution is real and rational, or real and irrational and imaginary. So this one will be the special case that I was talking about. So, but you don't have to look at it ahead of time, just use your discriminant to look at it. So this is the discriminant, b squared minus 4ac. Okay, b squared is negative 20 squared minus 4 times a is 4 times c is 25. So that's going to be negative 20 times negative 20 is 400. I'm still going to have the minus. 4 times 25, that's 100. Times 4 is 400. So square root of 400 minus square root of 400 is square root of 0. Square root of 0 is just 0. This is a special case when your discriminant equals 0. First off, is 0 a real or imaginary number? That's always the first thing you have to determine. Is your solution real or imaginary? 0 is a real number, so real. Is 0 considered rational or irrational? Well, I will tell you 0 is a rational number. Okay? So that would be rational. because when this comes out to be a perfect square, square root of 0 is just 0. So perfect square, so that means it is rational. And then the special case when your discriminant is 0, this is the only time you will use the word equal. When your discriminant equals 0, your solutions are the same thing. And I'm going to factor this out. Remember, when you have a perfect square, this tells you that this thing will factor, that this equation will factor. Okay, so if we factor this, this will come out to 2x and 2x and 5 and 5 plus, oh wait, they're both going to be minus, 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 minus. Okay, that will give me a negative 10x, which means negative 20. When your solutions are equal, these parentheses have to look the same in order for them to be equal. I have two equal solutions, so I can see from here that my solutions, moving the 5 over and then dividing by 2, x equals 5 over 2 for both parentheses. So that's what it means when your solutions are equal, that these parentheses will look the same and you will have the same solution. This is called a double, that's called a double root solution, meaning that both solutions are the same thing.